Hi, professors. This is Jiarui. The topic of my final project is Graphic User Interface, Online Gaming, and Secure Messaging. This presentation is divided into 6 parts: Introduction, Demo, Details about GUI, Online Gaming, and Secure Messaging. Finally, the conclusion. My motivation was to create a more user-friendly interface. So for the GUI, based on the starting code, I add some shortcut functions like buttons, and I bind some send buttons with enter on the keyboard, so users could send messages more easily. And I want to increase the playability, so in the chat system, I add a small, simple game function, because 2048 is a single-player game, so I add a scoring and ranking system to increase competitiveness. Then to improve users' privacy, for the GUI, I add a login password function, and I use the RSA encryption, decryption, and digital signature to increase the security of the communication process. Let's watch the demo first. First, start the server, then client. If you log in without an account, there will be a message box indicating that the account does not exist, so you need to register first. Then you enter the chat room. You could send something following the prompts, or you can just click the shortcut buttons below. When you type something into the entry box, you could click Submit or Send, or just press Enter on your keyboard. You could play the game now. Above is the real-time score and highest score ever for that user. After playing the game, you could also search the rank list or other players' rank and score. Now, let's connect with a peer. Connected successfully. Actually, from the client side, you could see that every message you receive is securely encrypted and verified. Let's take a look at the GUI. The package I use is TickInter, and as I mentioned, the main functions are login password and register, and some shortcut buttons. This is the login and register window. On the right is part of the login function. In the self.pass input entry box, I define the parameter show equals to a asterisk, so the password you enter will not be displayed, but instead some asterisks, which could protect users' privacy. The self.goToRegister defines the register button that leads to the function register, and the self.go is the continue button, which leads to the function go ahead. This is the register function. It has the username and password, label, and entry box. Self.nameInFocus set the cursor focus to the first input box, and the register button leads to the go register function. Here is the go register function. If your username or password is empty, or your username has been used, then it will have a pop-up window to show the warning. If registered successfully, it will also have a pop-up window show that you're successfully registered, and then you could go back to login. Here is the go ahead function, which functions when you click the continue button in the login window. It will send messages to the server to check if your username and password are correct, if you have registered for an account, and if you have repeated logins. Then you could get into the chat room. Here's what I add to the chat server to complete the login and register step. These check whether name and password are valid. This is the layout of the chat room. For the shortcut buttons below, we take point as the example. First, we define a shortcut point button in the main chat room layout. Then the command of the button is give point. In the give point function, it's a pop-up window and has a label entry box and button. Once you click the button, it will send you input to the server with the send button function, which is defined in the starting code. And we can see at the end, there's an event, which is bound to the return key. So when you finish typing the content, you can just press enter on your keyboard instead of clicking the button. Now, let's move on to the online gaming, because the game code is mainly downloaded from the internet. So I will just explain the scoring and ranking system and how I integrate it into the chat system. When the user clicks to play, then his username will be written into the player.txt. And the server will send a welcome message to him, and the state changes to gaming. In the gaming state, I use a thread so that user could quit the game successfully and get back to the chat room, and then the user state converts to logged in. For the scoring and ranking system in the game file, when the game is over, it will record the score in the scores.txt. So this corresponds to the player's name it recorded before. Then we read the player's file and the scores file to put data into dictionaries. We use collections to ensure that the order of the ranks entered is the same as when they are read afterwards. In the menu, I add 3 more functions. Rank is that it will send the whole rank list back. Score plus player name is that it will send you the highest score of that player. In the server file, these actions are all rank, so that the server will send the rank dictionary back. This dictionary includes player and his score, so we could use the enumerate function to get the number of the rank. This function is to check the ranking of the specified player. Then the last topic, secure messaging. If you want to tell your friend a secret, you could write it down or mail it to them, or use the phone. But each of these communication channels is insecure, and anyone with a strong enough motivation could easily intercept the message. One solution to prevent eavesdroppers from accessing message contents is to encrypt it. The RSA algorithm is the first algorithm that can be used for both encryption and digital signatures, and it is easy to understand and operate. Here's the packages I use. Let's have a look at the encryption and decryption steps first. First, in the client file, we add 2 global variables. In the generate client key function, it generates a pair of public and private keys and save it to the PEM file separately. Because each user has its unique username, so we save their keys in different files. We assume that anyone can access your public key file, but not your private key file, and once you logged in, it generates your keys. The flag variable is that when you change your state from chatting to logged in, your keys won't generate again. Here are the encrypt and decrypt functions. When communicating, the sender uses the receiver's public key to encrypt, and the receiver uses the receiver's private key to decrypt. From the code, we can see that the encrypt function needs 1 more parameter, the peer's name. Then it could read the peer's public key to encrypt the message. In this function, we need to first encode the message with UTF-8, which converts it into bytestring, or this will raise an error. Then, once the user tries to send a message to the peer. Here we assume that there's only one peer. We get a peer's public key and use the encrypt function to encrypt the message. Then once you receive a peer's message, you use the decrypt function. Here we complete the functions, so every message sent and received is encrypted. But since every user's public key is public, everyone can access it, so the eavesdropper has the opportunity to use the receiver's public key to fabricate a message to him. Thus, we use the digital signature function. That is, when the sender sends a message to the receiver, he first signs the message to indicate his identity, and this signature cannot be forged. The process is that the sender uses his private key to sign the content, and then the receiver uses the sender's public key to verify the signature. And in these two functions, I also use packages to reduce the workload. Here we can see, once you send a message, first encrypt it, then use your own private key to sign it. Then before putting it into the JSON dumps, you need to convert it into string type, or there will be an error since that it's not JSON serializable. Then on the server side, you also need to exchange the signature when it exchanges messages. Then, when you receive a message, you need to verify the signature using the sender's public key. Also, remember to convert it to byte type before using the verify function. If it's verified successfully, receiver will get message, otherwise he won't. In conclusion, in this project, I optimized the original graphic user interface, add the online gaming function and its ranking and scoring system, and also the RSA encryption and digital signature to protect the security of the communication. But there are still many improvements need to be made. For the GUI, emoji, file transfer, and other settings can facilitate communication. And user's unique profile photo is also an interesting feature, but I didn't have time to do. And also, I think some pop-up windows need to be set to close automatically after the user submits something in the entry box. For the online gaming part, we need to optimize the reading of player scores. Because if the player quits the game before game over, then his score won't be recorded into the score file, but his name is already in the player's file. Second, there should be a multiplayer mode for gaming. But because I think the game 2014-8 is totally for the single person, so we could actually add some multiplayer games into the chat system to further develop the playability. For the secure messaging, actually, RSA encryption is often used in combination with other encryption schemes. It isn't generally used to encrypt entire messages or files, because it's less efficient and more resource-heavy than symmetric key encryption. So I think to make things more efficient, the message could be encrypted with a symmetric key algorithm, and then the symmetric key will be encrypted with RSA encryption. Under this process, only an entity that has access to the RSA private key will be able to decrypt the symmetric key. This could also ensure the security and improve the efficiency. That's all for my sharing. Thanks for watching.